Hey everyone! In this video I'm going to show you how you can create a level editor using Unity's Tilemap system. Well, actually I'm not gonna show this entire thing yet, because this is gonna be a tutorial series. In this video I'm gonna show you how you can place tiles to the tile map using your cursor, and how you can save those tile maps. Let's go! I've prepared a completely new Unity project, which only has a few things in it. I imported my tools so I can create tiles very quickly, and I also imported some tile maps, so we have something to work with. Everything else is completely as it is when you create a new project, so let's just set up a few things. Let's create a tile map, which you can do by going to the hierarchy, right-clicking, to the object, tile map, and just a regular rectangular tile map. This will create a grid and a tile map for us. And let's also create a tile palette, which you can go by going to Window, 2D, opening the tile palette window, and then clicking on Create New Palette. Now we can take our prepared sprites and just drag them into the tile palette. Now we have simple sprites which we can take and draw with them, but let's make things a little bit easier for us, and let's create a rule tile. I've created a really easy to use tool which you can use to create rule tiles really quickly. And if you want to know how it's made, you can check out my tutorial on it, link in the description or the top right corner. So let's go Windows, Editor, Windows, and Rule Tile Generator. And as you can see, it created a perfectly working rule tile which we can use. Okay, so we have everything set up, so we can start creating the actual level editor. Let's create a new folder for our scripts. And let's create a few scripts. We'll create a level editor script. And let's also create a level manager script. Let's open it. Before writing the code, we need to add some using text. First, we need Unity engined Tilemaps. Let's create a few variables. In order to edit a tile map, we need a reference to the tile map. So let's create a reference to the tile map, current tile map, and we also need some tiles to place on the tile map. So let's add just one tile for now, which will be the current tile. We're using the tile base, so we can put any kind of tile in it. So let's say you have just a regular tile. If you're doing this, you will not be able to assign rule tiles, for example. So we need to use tile base. And we also need a reference to the camera to calculate the mouse position. So we pretty much have every reference we need. So let's create a placeTile function. This function will take in the position where we need to place the tile, which uses vector-free ints. To place a tile on a tile map, we just need to write the tile map, so current tile map dot set tile, which takes in the position, so it's just pose, and the tile, which is the current tile. Placing tiles is that easy, but we need to figure out the position somehow, so let's write something in the update function. Based on the camera and the mouse position, we return the coordinate of the tile which we are hovering over. So let's create a temporary vector-free int called pose, and this pose variable will be equal to our current tile map dot vert to cell, which converts a vert position to a cell position, and we'll get that vert position using the cam screen to vert point and just using input dot mouse position. We have our position now, so let's make so if we left click, we place down the tiles. If input the get mouse button 0, which is the left one, place tile at our position. So we can now test this script, so let's go to the grid for example, and let's add the level editor script. We need to assign the variables, so tile map goes to the tile map, main camera goes to the camera, and for the current tile, let's choose our rule tile, and we can press play and test it. And as you can see, when I'm left clicking, it places down tiles, which also automatically update as these are rule tiles. But yeah, I cannot delete them, so let's change that. Let's go back to Visual Studio and let's add another function, which is gonna be called delete tile. deleting the tile is basically the same as placing one, but instead of placing a tile, we'll just place null. Let's also add an if statement. If we are right-clicking, let's delete the tile. So we can now get rid of these tiles by right-clicking, and we can place new ones. Okay, so let's say we created a level. This is a pretty primitive level, and we want to save it. Well, we cannot, because if we exit the game, it's gonna get lost. So let's make the saving. Let's open the level manager and also add the using tags. As this is a manager, we only want one of this script, so we can make it a singleton. So let's create public static level manager instance, and in the awake function, if instance equals null, instance equals this, and if there's already an instance, let's destroy this script. Let's add the reference to the tilemap as well here, and let's create a save level function. Now, in order to save the level, we need some type of object that we can save it into. So let's create a separate class in this script called level data, and this level data will contain some variables. So let's think of what we need in order to load or save levels. Well, we need the tiles, and it's gonna be a list because we have multiple tiles in a level. Tiles. And we need their positions, so let's create a vector-free int list called poses. So let's go back to the save-level function. We need to get all of the tiles from the tile map and somehow write those tiles to a level data. So we need to loop through every tile on the tile map and write it to a level data. So if we go to tilemap, there's not a function called load all tiles or get all tiles. There's only get tile. So we need to figure out where are the tiles, because the tilemap can be like infinite long. Luckily, there is a function called tilemap.bounds, which will return the area where tiles are placed. So let's call this cellBounds function and save its output to a bounds int. And now we can take this bounds and loop through every tile in it. So for in the x-axis, we will start from bounds.minimum.x and we'll loop until we reach bounds.max.x. We'll do the same thing for the y-axis. Before looping, let's create a new level data. Level data equals new level data, and I forgot to set these tiles to new lists, so they're basically empty and we can work with them. So we can now use these x and y coordinates to get tiles from the tile map. So tilemap.getTile, new vector-free int x, y, and the grids have no depth, so the x coordinate will be 0. We will save this tile to a temporary tile. And to not save empty spaces, we'll check if the temporary tile is not equals to null, and if it's not null, we can add the position and the tile to the level data. Now we just need to save it somewhere, and the best way to save it is to convert it to a JSON and save that to somewhere on our PC. To convert this level data to JSON files, we can just use the built-in JSON utility. String JSON equals JSON utility that to JSON, and we just put the level data there. There's also an option to pretty print, so it will look like this, not everything in one line. Let's enable it so we can look at that later. And now we can write this JSON to a text file. We'll need the system.io namespace for that. So file.write all text. And here we need the path and the contents. The contents will be the JSON file, and our path will be application.datapath plus / our file name. So let's call it test level. We'll change this later to a variable so we can input our level's name and .json. We need to trigger this function somehow. So in the update function, let's assign this function to a key. Like every program, you usually save by pressing Ctrl S. So let's do the same thing here. So if input get key code Ctrl, and input get key down key code S, save level. So when we are pressing the S while holding the control key, we save the level. Fuck. Unity is gonna complain that we cannot save during play mode, so let's change the S to A. Let's also add the debug.load to let us know that level was saved. And we can now test it. Okay, we can now add manager object and add the level manager to it. And let's also assign the tile map. If we draw something and press Ctrl A, it's gonna let us know that the level was saved. So we can now exit play mode. My mouse battery just died. Fuck. After we exit play mode and let Unity refresh our stuff, the test level file will appear. This is our saved level, of course. So let's create something to load it. Go back to the level manager script and create the load level function, which will load the file at the exact same path as we saved it. String json equals the file, the reverse of the write all text, so read all text, and the path. I'm gonna just copy it. We can now convert this JSON file to a level data object. So level data equals JSON utility from JSON, the reverse of the toJSON function, type of level data, and the JSON file. To make sure the tile map is empty, we can do tilemap.clear all tiles, and then we can loop through every tile and place it. So for int 0 data.tiles count, because it's a list. We could also do poses. The count is the same, so it doesn't matter. And we can do tilemap set tile data.poses y and data.tiles y. Let's make a function to load the level. Let's use Ctrl O for that as open load level, and we can go back to Unity. So if I press Ctrl L, it works until you close down your program. So there's a problem with that. It stores instance IDs, which change every time you open your game, or in this case the Unity editor. So let's just close down the Unity editor. Okay, Unity is open now. I'm gonna create a duplicate of this so we can compare it once we save it again. And let's play the game. So let's draw something and press Ctrl L. It cleared the screen, so we know it's working, but it didn't place anything. We can see that the instance ID changed. That's the reason why we can't store Unity specific objects in JSON files, because Unity stores them as instances, which change every time you reopen Unity or the game. So let's fix this. Let's use a data type which is always the same. So the basic data types like bool, int, float, these stay the same and are supported by JSON files. So let's change the tile base to strings. Now we cannot use strings to place tiles. Visual Studio highlights this error. We need to create an ID system for the game. So let's go back to Unity, to the scripts folder, and create a new script, which is gonna be called custom tile. This is gonna be a scriptable object, which we can create using the asset menu. This tile will store two things. First of all, the tile and its name or ID. In the level manager, we need to store every custom tile which we'll be using in our level editor. So list of custom tiles should be a public list, and it's equals to a fresh custom tile list. So we can just add temp to the list now. We need to search through this tiles array, and if the tile is in the tiles array, we need to add its ID to the tiles. So instead of checking if temp is equals to null, we will check if we can find the tile in the tiles array and if it has an ID. So string temp ID equals to tiles.find t where t.tile equals temporary tile. This will return a custom tile, so let's change it to custom tile. And now we can check if temp tile is equals to null, and if it's not null, we can use its ID to save it. in the load method, we can do the opposite. So instead of searching for the title, we'll search for the name. So titles.find t, where t.name equals to our saved style in the data dot style. And in theory it should work now. So first let's create a new dirt. The IT is gonna be dirt, and the tile is gonna be dirt rule tile. And we can add this tile to the tiles array in the level manager. So we can draw, press Ctrl A to save the level, exit, refresh Unity, and now we can see instead of instance IDs, it stores strings, which is actually more space efficient than the instance IDs. We could also change the poses to two separate integers, poses x and poses y, and we also need to separate them. So in the setTile method we use new vector3 int poses x, poses y, and 0. And here we just need to add the x and the y separately. So poses x that add x, and poses.y add y. So let's draw something, save it, refresh Unity. And because it doesn't have to explain the x, y, and z property every time, it's gonna be shorter, as you can see. If we enter play mode again and press Ctrl L, it's gonna load it in with no problem. That's it for this tutorial. In the next part we'll implement the ability to place multiple types of tiles, and we'll also create an inventory to search and select those tiles. Until then, see ya.